Okay dude, so this video is going to be about quadratic equations in one variable. You have already learned how to solve it in class 9. Yes, so this year's portion is going to be a bit different. But before starting that, I'm going to tell you that what was the entire purpose of solving a quadratic equation. For example, in class 9, when you solved this equation x square minus 5x plus 6 is equal to 0, what were you actually trying to find out? Let me write down this one. X square minus 5x plus 6 is equal to 0. Okay, so you know that after prime factorizing 6 you get 2 into 3, so you write x square minus 3x minus 2x plus 6 is equal to 0. Yes, then you take from these two, you take x common and you write x into x minus 3. From these two you take 2 common and you write minus 2 into x minus wait into x minus 3. Yes, and finally you get x minus 3 into x minus 2. Yes, and finally you get the values of that x is equal to 3 comma 2. Yeah, I'm writing it over here because there's no space left. Yes, so finally you find out that x is equal to plus 3 and x is equal to plus 2. Yes, you find that out. So what is this 3 and 2? This 3 and 2 are roots of the equation. Understood? So 3 and 2 are roots of this equation. Now if you put this value 3 or 2 back in the equation, I again write x square minus 5x plus 6 is equal to 0. Now if you put the values, and I had got that 3 comma 2 are roots of the equation. Yes, so if I put 3 instead of x over here, then it becomes 3 square minus 5 into 3 plus 6 is equal to 0. Yes, which becomes 9 minus 15 plus 6. Yes, 9 plus 6 is 15 and 15 minus 15 is 0. So if you put the values 3 or 2 back in the equation, then you get 0. Understood? So this is the main point of this whole exercise, that if you put back the roots in the equation you will get a 0. Yes, so 3 and 2 were the roots of the equation. Now we will put 2. Okay, so 2 square is equal to 5 into 2 plus 6 is equal to 0. Yes, 2 square is 4, minus 5 into 2 is minus 10, plus 6 is equal plus 6. So 4 plus 6 is 10 and 10 minus 10 is 0. Yes, so again if you put back 2 in the equation you get 0. So this is the rule which we will be working on all throughout this exercise, that if you put back the roots in an equation, in a quadratic equation, then the answer is always 0. Yes, so this is the main point of this whole exercise. Yes, now we will get back to the exercise. So now look at the first question. Check whether the following are quadratic equations or not. Yes, so what does a quadratic equation have? For example, the previous one which I wrote on the board, x square minus 5x plus 6. What does this equation have? This equation has a x square. Yes, this equation has a x, and this equation has a normal number like 6. Yes, so these are the three things which should be present in an equation so that you call it a quadratic equation. What are they? X square, x, and a number. Yes, so now let's look at the first equation, that they are asking you whether root 3x square minus 2x plus 3 by 5 is equal to 0 is a quadratic equation or not. So from here only it is pretty visible that it has a x square, it has a x, and it has a normal number. Over here it is a fraction, yes, but still it can be considered as a normal number. So yes, this is a quadratic equation, yes. So we will solve it. So there's a bit of problem with the fraction, yes. So we will solve this equation, yes. So what do I do? I've taken, like as you see in this, I've I've taken 5 for 3 by 5. I've taken 5 as the LCM. Yes, over here it is root 3 by 1. Over here it is 2 by 1. And over here in the third one, it has the denominator 5. Yes, so 1 into 5. So 1, you have to multiply it with 5 to get 5. So, and this is normal things. I don't think that I need to explain this in detail. So finally, if you take out the LCM, you get 5 root 3 minus 10x plus 3 is equal to 0. Yes, this 5 this 5 at the bottom, you cross multiply it and finally becomes 0, because 5 into 0 is 0. And finally, what do you get? You get 5 root 3 x square, so there is a x square, minus 10x, so there is a x, and plus 3, which is a number. Yes, so it is a quadratic equation. Yes. Okay, dude, so the next one is 2x plus 1 into 3x minus 2 is equal to 6 into x plus 1 into x minus 2. All you have got to do is multiply this normal simple class 7 algebra. Yes, you need to multiply these two, and then you need to multiply these two. So first, on the right hand side of the equal to, if you see these two, x plus 1 into x minus 2, you will multiply it first. Whatever answers you get, there will be 4 things in that answer. Yes, so you will multiply that with 6 after that. don't don't multiply that 6 don't multiply 6 into x plus 1 as 6x plus 6 and then further multiply it with x minus 2. Don't do that. First you will multiply x plus 1 into x minus 2, and then after that you will multiply it with 6. Though I don't think that if you first make it 6x plus 6 and then multiply it with x minus 2, there will be a difference. So you can check it out. Yes, but this is what you're doing. And after that, finally, after taking everything to the left hand side, because after solving this right hand side, you'll finally take it to the left hand, take everything to the left hand side and solve it. Yes, so if after that whatever answer you get, there is a x square, there is a x, and there is a normal number, then you will then it is a quadratic equation. Okay, so now we move on to the next sum, which is sum number 3, where they have given you that x minus 3 whole cube plus 5 is equal to x cube plus 7x square minus 1. You need to solve this entire thing, and you need to figure out that whether it is a quadratic equation or not. Yes, so the only problem in this equation which I can see right now is that there is a x minus 3 whole cube. So first we will solve this. So moving on to the next page, x minus 3 whole cube, it is of the form a minus b whole cube. So the formula for a minus b whole cube is a cube minus b cube minus 3ab into a minus b. Yes, a cube minus b cube minus 3ab into a minus b. Yes, so we need to do x minus 3 whole cube. We need to do x minus 3 whole cube in a similar way. So x cube x's cube which takes the place of a cube, and 3 cube which takes the place of b cube. Yes, so x's cube minus 27 because 3 cube is 27 minus 3ab. 3ab is what? 3 into x into 3. Yes, so 3x and finally 9x minus 9x into a minus b, which is x minus 3. Yes, finally after solving, what do you get? X's cube minus 27, and after multiplying minus 9x with x you get minus 9x square, and after multiplying minus 9x with minus 3 you get plus 27. Yes, so the final answer is x cube minus 9x square plus 27x minus 27. Okay, so this one we have just solved the x minus 3 whole cube portion. Yes, the remaining equation is still left to be solved. Okay, so now I copy down the whole equation once again. X minus 3 whole cube plus 5 is equal to x cube plus 7x square minus 1. Yes, so x minus 3 whole cube, I had got the answer that x minus 3 whole cube is x cube minus 9x square plus 27x minus 27. So I will write down the same thing instead of x minus 3 whole cube. x cube minus 9x square plus 27x minus 27. Yes, plus 5, which is okay dude, where was I forgot. Okay, so we'll start from the second step once again. X minus 3 whole cube is x cube minus 9x square plus 27x minus 27. Yes, and we bring down this plus 5 from over here. Yes, is equal to x cube plus 7x square minus 1, which was there in the sum itself. Okay, so now we can see that x cube and x cube cancels out from both sides. What remains is, and the remaining things on the right hand side we will bring it to the left hand side. For example, this yes, for example this 7x square. Okay, first after that I have solved that there was a minus 27 plus 5 on the left hand side. Minus 27 plus 5 is minus 22. I have solved it. Yes, and 7x square minus 1, which has come down from here after the x cube got cancelled out. Okay, so now I will bring everything to the left hand side. Okay, so 7x square will go to the left hand side, so it is there with 9x square right now. So it will be minus 9x square, which was already there, and minus 7x square, because plus 7x square when it comes to this side of the equal to, it becomes minus 7x square. Yes, there was already a plus 27x which we will write again. Yes, and there is nothing on the right hand side which has got the variable x, so 27x remains alone. Yes, and there was a minus 22 which we write again over here as minus 22, and this minus 1 when it goes to the other side of the equal to, it becomes plus 1. So finally it is equal, everything is equal to 0 because we have emptied the right hand side, so it is 0. Now minus 9x square minus 7x square is minus 16x square. Yes, plus 27x we write it down as plus 27x, and minus 22 plus 1 is minus 21. Yes, so finally we get our final equation. Now we need to verify that whether it is a quadratic equation or not. So we can see that there is a x square over here. Yes, we can see that there is a x over here. Yes, and we can see that there is a constant over here. Yes, so all the three conditions are satisfied, so yes, it is a quadratic equation. Yes, now we move on to number 4. where we see that they have asked us to check whether x minus 3 by x is equal to 2 is a quadratic equation or not. So first I'll take the LCM as x, yes, and finally I get x square minus 3. Yes, just to show you how I get to x square minus 3, see x minus 3 by x, if we x minus 3 by x, we take x as the LCM. Here it is x by 1. 1 into how much is x? 1 into x is 1 into x is x. So this x in the numerator, we will multiply it with x only. Minus, here x is already there. Yes. So nothing to multiply it with. So we will write 3. X into x is x square minus 3 by x. Okay. So that's how I get to x square minus 3 by x is equal to 2. Okay, so now finally I will cross multiply. So I will multiply x with 2 and it becomes 2x. Okay, so finally it becomes x square minus 3 is equal to, it becomes x square minus 3 is equal to 2x. Now I will bring this 2x to the left hand side. It becomes, 1 minute, it becomes x square minus 2x minus 3. Yes, so now we need to verify whether it is a quadratic equation or not. It has a x square, it has a x, it has a constant. So yes, it is a quadratic equation. Then we have the next sum where they ask whether x plus 2 by x is equal to x square or not, is equal to x square. They are asking whether it is a quadratic equation or not. So this one also you're solving it in the same way in which the same way in which how we did the previous one. Yes, and then we move on to the next one where x square plus 1 by x square is equal to 3. Again you're going to solve it in the same way as we solved number 3 or number 4, whatever it was. What was it? It was number 4. Yes, so the next two sums you're going to solve it in the same way in which we solved number 4. Now we look at the next sum number 2. What are they asking you? That in each of the following determine whether the given numbers are roots of the given equation or not. So here they have given you a quadratic equation, x square minus x plus 1 is equal to 0, and they have given you two values, 1 and minus 1. Yes, so you are supposed to find out whether 1 and minus 1, these are roots of the given quadratic equation or not. Yes, so how will you find out whether 1 and minus 1 are roots of the given quadratic equation or not? You are going to put these values in this equation. You are going to put 1 in the equation, yes, in place of x, and then you're going to put minus 1, then you're going to put minus 1 in the equation in place of x. If the final answer is 0, then they are roots of the equation, and if the final answer is not 0, then they are not roots of the equation. Yes, so we will straight away jump to the sum number 2 is 1, which we see over here. The equation is x square minus x plus 1 is equal to 0, and we need to check whether 1 and minus 1 are roots of this equation or not.